a little check mark on this one. So far, we stated the mother of them all. We didn't prove it yet, but using it, we tweaked it to get that one. We tweaked that one to get that one, and then we proved this one using the other things we had proven already. You, my friends, you should be able to finish everything and own it. Prove every single one of these and say, hey, I know exactly why each of them is true. There's one thing left to do, and one thing only, and that is explain exactly why this one is true. Cosine of A minus B is equal to that. That's the mother of them all. Everything comes from the mother of all. That's the biggest tomato plant in the world. You get all the tomatoes out of it. So that's the last thing that we got to do, is we got to prove the mother of them all. Okay, let me put this on pause and recharge the batteries here for just a second. Okay, now to prove the mother of them all, there are two crucial ingredients that we need. Absolutely crucial ingredients. The first one is how to find the coordinates for a point when you know this angle is theta and you know that this is r units long. You must absolutely know what the coordinates are for this point. The coordinates means you got to know what the x value is and the y value. Fortunately, to know the x and the y value there, it's not that hard, because we've already got enough tools to figure it out. We could make a right triangle out of this, and we know all about these right triangles. Suppose you call this distance x and you call this distance y. Then we know that cosine theta would be the ratio of x over r. So therefore, your x value is equal to r cosine theta. And that right there, that tells you what the x coordinate should be. It should be r cosine theta. Okay? And for the y value, you can call this value right here y, and then you think to yourself, well, this would mean that sine of theta would be the ratio of opposite to hypotenuse. This would be y over r. That makes y equal to r sine theta. And so this would become r sine theta. And it's incredibly important for you to really know this. So let's see if we can practice just a little tiny bit this idea. Suppose I have this is 5 and this is I don't know 23 degrees. Then what exactly are the coordinates here? It should be automatic. The x coordinate would be the r times sine of the angle, or sorry, r times cosine of the angle and r times sine of the angle. So this would be 5 cosine 23 degrees, 5 sine 23 degrees. Just like that, you should immediately be able to tell me the x coordinate and the y coordinate here. Okay, it should be automatic. We'll try that again. Suppose that this guy is 1 and this is a house. Okay, what are the coordinates here for this point? There will be 1 cosine house and 1 times sine of house, and those would be the exact coordinates for this point right here. Suppose that this one was x or no theta plus beta. Okay. And this one was 7. If this angle was theta plus beta, this coordinates here would be 7 of times cosine of theta plus beta, comma 7 sine of theta plus beta. Okay, that's exactly how you find the coordinates. Whenever you know this length r and this angle blah, whatever it is, it's just exactly like this. You take the r times the cosine of the angle, comma r sine of the angle. That's absolutely crucial. One of the crucial elements to prove the mother of them all. You must be good at finding the coordinates for any one point. Okay, second ingredient. Second crucial ingredient is the famous distance formula. Now, let me review that for you. Suppose you've got a point here, and this point is, I don't know, let's say it's 3, 5. And suppose you've got another point here, and this point is 10, 1. there's a famous question here, and that famous question is, what is this distance? What is that distance d? And the famous way to look at it is to make out of this distance segment, make out of it a right triangle, kind of like this one. And then if it's a right triangle, then if we know these two sides, we can use Pythagoras. It'll be Pythagoras time, and we can find a third one. Let's think about this. This x value was x equals 3, and this value was x equals 10. I'm looking at the x values here, 3 and 10. 3 and 10. How do you figure out the distance between 3 and 10? Well, it's very easy. You just go 10 minus 3, and that's equal to 7. So I'll just write 10 minus 3. Or I could write 7. It doesn't matter. Same thing. And then to find out this distance, you will look at the y-coordinates. This y is equal to 1. And this y over here is equal to 5. So how do you figure out the distance between 5 and 1? Well, you would do 5 minus 1. Or you could write 4, whatever. And then once you do it this way, then it's easy to find the distance, because this side is 4 and that side is 7. So you got that 4 squared plus 7 squared is equal to d squared by Pythagoras. And then you would add these and take the square root maybe. A lot of times people write it this way: the distance is equal to the square root of the 10 minus 3 squared plus the 5 minus 1 squared. And this is the so-called famous distance formula. You can do that if you don't want to think, but if you want to think about understand things, this is where it comes from. It comes from making a right triangle out of this guy. So you must be good at looking at 2 points and finding the distance between them. Let me practice that one more time, and we'll put it here on our summary of ingredients. So this is, I told you need 2 key ingredients to prove the mother of them all. One of the key ingredients is this right here, being able to find the coordinates. And once you've found the coordinates, you must be good at finding the distance between 2 points. So I'm going to call these points, I don't want to call them 3 and 5 like I did before. I want to be a little bit more general than that. So if this distance is d, and if this point is, let's say this point is, I don't know, call it K, R, I'll call this one H, P, doesn't matter. Then you should all know that the distance, the square of the distance is given by, you look at the x values, you hear your x values, K and H. So you do something like this, K minus H squared. That would give you this distance right here. See, a lot of times people don't even write this triangle, but you can use it to figure out. This is your H, this is your K. So this is K minus H squared, that's this side. Plus, you're going to look at the y coordinates now, P and R. So it'll be P minus R quantity squared. That's famous. That's called the famous distance formula. These are the absolutely 2 non-negotiable ingredients. You must be really, really good at these if we're going to prove the mother of them all. The mother of them all, you got to be good at these 2 ingredients. Finding the distance formula, or using the distance formula, and finding the coordinates for any one point where you know the angle and the length of the segment. Okay? Those are the 2 ingredients. Now there's only one thing left to do, and that is to prove the mother of them all. Okay. Now here's the key to proving the mother of them all. You first start off with a segment of length 1. There it is, a segment of length 1. And we'll call this angle angle A. A will be exactly this angle. Okay, and this would be length 1. Now we've already practiced, that's why I left these up here. When you have an angle theta and a length, you should be good at finding the coordinates for that. So let's see if we got that. Let me see if I can somehow just a little bit so you can see both. If this is 1 and that's A, what would be the coordinates here? It will be 1 times a cosine A, comma, sine A times 1, which is the same thing as sine A. Those would be the coordinates for that, using one of the ingredients that I told you we needed. And then the other thing to do would be to draw another segment. Let's say this segment, and this segment will be angle B, and then we'll make it also length 1. And then that means the coordinates here would have to be cosine B, comma sine B, and then the idea would be to pretend that there's some person here, some guy or girl, and this person is holding up the triangle with their hands, and of course you need a triangle to hold up this triangle right here, and it's preventing it from falling. And they're kind of like smelling their armpit or something, raising their hand and holding the triangle. And then the key here, this is, by the way, you know, keep in mind what we're trying to do. They were trying to do this mother of them all. We're trying to prove that. And just to keep things straight, which of these methods are we using to try to prove that? Working on one side? I don't think so. Tweaking, nothing. It is starting with something amazingly creative and brilliant. Who would have thought that this guy holding the triangle would eventually help you prove that the mother of them all? But it is. It's something amazingly creative, and you're gonna see why they pay me. So the idea here, this is the amazingly creative idea. You have this person holding the triangle, and you call this distance D, and then this person kind of feels like walking away, and they start walking that way. Whoa, if they start walking that way and they let go of the triangle, guess what would happen? This would happen. The triangle would fall. This is the key right here. This is the amazingly creative idea that the triangle would fall. I know it sounds crazy, believe me. I know. But it is. It's exactly the brilliant idea, the triangle falling. Because look, when the triangle falls, you're going to be left with this. Let's look at the picture after the triangle has fallen. This part right here falls right on the ground, and it'll be right here. And now, the length of the segment was 1, and then the angle B is killed. So what would be the coordinates for this point? It would be just 1, 0. And then the other part of the triangle would be right over here. Something like that. It would still be length 1. That's this piece over here. And here's the triangle fallen. There's your distance D. But now let's think about this angle right here. This angle used to be, the whole thing was A and the little one was B. That right there would be the difference between them. So that would be definitely, it would be A minus B. That would be the angle. The angle now for this one. That would be the same as this angle right here. A minus B. And now we practice this. Once you know the angle, you should be very, very good at finding the coordinates for that point right there. And those coordinates would be cosine of A minus B times 1, of course, but I don't need to multiply by 1 because it's the same thing, and then sine of A minus B. Right? Those would be the coordinates. Now, as crazy as this sounds, this is exactly all you need. You have the triangle, and then this guy's holding it up, and then the guy walks away. He's over here now, away from the action. He says, oops, I dropped it, and then it fell down, and as amazing as it sounds, that's all you need. But all we got to do now is just do the algebra and see what happens. The brilliant idea is to say that the square of this distance, that distance is exactly the same as that distance over there. You agree? Because this person didn't change that distance. All they did is walk away and let the triangle fall. It's still the same triangle. It's just fallen now. So this distance here must still be equal to that distance there. In fact, if I square this one, it's still the same thing as that one squared. That hasn't changed. And so the idea now is to calculate it in both ways. Calculate it here. That's why I said there are two key ingredients. One of the key ingredients was being good at recognizing the coordinates for a certain point. The other idea was good at being able to write the distance squared using the distance formula. Now it's time to use this idea. So I've got these 2 points here, and I gotta use the distance squared formula. So I gotta go difference of x's. So it'll be cosine. Gotta do this slowly. Cosine b minus cosine a, that quantity squared, plus sine B minus sine A, that quantity squared. That's what the left side equals. Okay? They're all going to be equal to the same thing. I'm just going to work on the left side for a little bit. Let me zoom you in there so you can see. This is a binomial squared, so I got to do the FOIL stuff or whatever you learn in grade school. If you do that, you get something like this: cosine squared B minus 2 cosine B cosine A plus cosine squared A. That's just this piece right here. Plus, I'm running out of room, so I'll write below here sine squared B. That would be sine squared B minus 2 sine B sine A. That was a little typo. Sine, I'm foiling this, sine B sine A plus a sine squared A. That's a negative sine A times a negative sine A. Gives you sine squared A. That's the left hand side, and it looks like a huge mess, but it cleans up nicely. Look at this. What is a cosine? This is, by the way, is added, right? That's this summation sign. That plus that plus that plus that plus that plus that. I can reshuffle the terms a little bit and write it this way. I may need to zoom out so you can see this. I put these two together, so it's cosine squared B plus sine squared B. That's these two right here. Okay? And then I got to add, but by the way, this is famous. Cosine squared B, sine squared B. What does that remind you of? That should remind you of the famous Pythagoras identity. Sine squared and a cosine squared. Every time you're adding those with the same angle, that gives you 1. That's exactly what we have here. Cosine squared B and sine squared B, that's going to be equal to 1. Similar thing over here. We have a cosine squared A plus a sine squared A. I know these two are going to clean up into 1. So really all I will have will be these two minus 2 cosine B cosine A minus 2 sine B sine A. And I'll deal with those later. But this is equal to 1 and that's equal to 1. So when it's all said and done, that gives me 2, 1 plus 1. This whole thing is 1. This whole thing is 1. So therefore that guy is equal to it's equal to 2 minus 2 cosine B cosine A minus 2 sine B sine A. And that's as far as I want to clean it up for the moment. That's what happens when you calculate this distance here using the distance formula. You get that, and then you clean it up. It looks kind of messy, but it cleans up nicely. That's what you get. Now let's put this on hold and go to the other side. Now on this side, I still have the coordinate here, and that coordinate there, and that coordinate there, and that coordinate. I can use the distance formula to get the square, and that would be something like this. It will be cosine of A minus B minus 1, the quantity squared, plus sine of A minus B minus 0, the quantity squared. That's using the distance formula. And that, we got to clean that up, so that will give you cosine squared of A minus B minus 2 cosines of A minus B plus 1 plus sine squared of A minus B. And that's it because I got 0 there. That's what that turns into. And then this cleans up nicely too because this is a cosine square of blah and a sine square of blah. Again, I'm going to use Pythagoras, something we've already proven. Every time you got sine squared blah plus cosine squared blah, that's equal to 1. So this becomes 1. This one right here and that one right there added together give you 1, plus another one that I have here. That gives me a total of 2 minus 2 cosine of A minus B. And that's how this one cleans up the right-hand side after you take the triangle and then you walk away. Sorry, you walk away and the triangle falls and you move that way, and then you calculate the distance again and you say, hey, those distances have to be the same. Nothing happened. This is all I did is fall. And so you clean this up, you get that. You clean this up, you get that. So these two must be equal. Whoa, 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 whoa. If these two are equal, that means I could subtract 2 from both sides, and that's still equal. And more than that, I can multiply both sides by or divide everything by -2, and that will give me the following. That will give me that cosine B cosine A plus sine B sine A is equal to, divide everything, divide that by -2, divide that by -2, divide that by -2. It gives me cosine of A minus B. And that, my friends, that's why they pay me. Look at this. The mother of them all delivered. Cosine of A minus B. That's supposed to be a cosine and a cosine plus a sine and a sine. Cosine, cosine plus sine, sine. I told you. That's why they pay me. Insane amounts of money. This is all you got to do. Let the triangle fall. You see that? Alright. I think I'll stop here. Here's what you got to do now. On the homework, you got to redo everything. You got to own it. Make sure you can prove the mother of them all. And then let the tweaking begin. Start tweaking it to get that one like we did in the lecture. Like we did that one. Every one of these you should own. These are super, super famous. You got to own them. And after you've owned them, then I put on the homework a few non-famous ones that should just help you. All you do is just practice proving identities. You will use these to prove all the non-famous ones. Okay? I think I'll stop there. Peace. We'll see you guys here next time.